10 true most disturbing substation horror stories. Tonight on Fear Knocks, we stand at the fence lines where dry weeds lift and the air tastes like metal. These accounts come from line crews, relay techs, night operators, and guard logs gathered after alarms reset themselves. Flat prairie under low cloud, frost on gravel, wind that threads through chain links and turns wires into a quiet choir. Hear a yard light warm with no feed, a control room speaker breathe across a muted channel, and a breaker cabinet tick like a watch in a pocket. Human threat moves as a copper thief with a borrowed vest and a smile at the gate. Natural hazard lives in arc flash, cold snap on insulators, and a gust that drops sleet across bus bars. If you have waited while relays think, this is for you. These are real crews and real notes, so listen close. Drop your own story below. We read them all. All right, let us get into it. I have been a relay technician for 17 years, mostly operating in the industrial parks and remote substations of the upper Midwest. My job is about certainty, voltage, current, resistance. We apply tags, we lock out sources, we test for dead. It's a fundamental, non-negotiable principle of electrical work. If the energy source is isolated and tagged, the circuit is dead. Period. My tools are extensions of that certainty. Multimeters calibrated annually, insulated gloves rated for thousands of volts, the heavy steel of a lockout box. I've seen my share of strange faults. Squirrel nests in switchgear, corroded bus bars, even a transformer core that hummed a perfect C-sharp for 3 days straight. But they always had an explanation, however improbable. This incident happened in early December, just after midnight. The temperature had dropped to 12 degrees Fahrenheit, and a thin, crystalline frost had settled on everything. Dispatch called me out for a routine inspection at the east yard pole of the old manufacturing plant. The plant was mostly automated now, running a skeleton crew. But the exterior lighting was critical for security. The work order specified a check on the sodium vapor yard light at pole 7, which had been flickering intermittently. My instructions were clear. Isolate the circuit at the main panel, apply a lockout tag, then proceed to the pole for visual inspection and voltage verification. I drove my utility truck through the silent, empty yard, the tires crunching on frozen gravel. The air smelled sharp, like ozone and cold steel. I parked near the main electrical building, grabbed my gear, and headed inside. The main panel was a familiar beast, a wall of gray metal cabinets. I located the breaker for the pole 7 yard light circuit, confirmed its label against my work order, and threw the handle. The satisfying clunk echoed in the quiet room. I then applied my personal lockout device, a bright red clasp that physically prevents the breaker from being re-energized, and affixed my orange danger tag. My name and contact information were on it, along with the date and time. 0037. Protocol dictates this is the absolute guarantee of a de-energized circuit. I radioed dispatch to log the tag out. Back outside, I walked toward pole 7. It stood about 40 feet high, a galvanized steel column topped with the familiar, yellowish-orange fixture of a sodium vapor lamp. As I approached, a soft, diffuse glow caught my eye. It was faint at first, just a hint of amber against the dark, frosted landscape. My breath plumed in the cold air. The light was on. My initial reaction was a surge of professional annoyance. Someone had bypassed my tag? Or had I pulled the wrong breaker? I quickly pulled out my work order again, confirming yard light pole 7 and the breaker number. It matched. I checked my lockout device in my pocket. It was still there, secured to the breaker. I walked closer to the pole, my boots scraping on the frozen ground. The sodium vapor lamp was now warming to a steady, unmistakable glow. It wasn't full brightness, but it was certainly active, humming with that characteristic low-frequency buzz. On the glass lens, a delicate filigree of frost had formed, but as the light warmed, I could see it begin to recede. A slow pulse like breath as the ice crystals turned to vapor, revealing the clear glass beneath. This was impossible. Absolutely impossible. I pulled out my multimeter, set it to AC voltage, and carefully extended the probes. I climbed the pole's integrated steps, clipped my safety harness, and reached the fixture. With insulated gloves, I tested the leads feeding into the ballast. 0 volts. I checked phase to ground. 0. Phase to neutral. 0. My meter, a device I trusted with my life, showed nothing. No potential difference. Yet the light hummed, radiating heat into the bitter cold, slowly clearing the frost from its lens. I descended the pole, my mind racing. I considered every possibility. A capacitor discharge, perhaps? But sodium vapor lights require a high-voltage pulse to strike the arc, then continuous current to maintain it. A simple discharge wouldn't sustain a glow, let alone warm up. It was actively consuming power. I radioed dispatch. "This is Unit 1. I'm at pole 7. The yard light is on." A pause. "Unit 1, confirm tagout status." "Confirmed. Breaker is tagged out at 0037. No voltage at the fixture." Another pause. "Unit 1, repeat. The light is on, but you have no voltage?" "Affirmative. The light is on. Warming up even. But my meter shows dead." Dispatch contacted my supervisor, who was already on call. He arrived 15 minutes later, his face grim in the headlights of his own truck. He went through the same steps I had. He checked the lockout box, confirming my tag. He walked to pole 7, saw the glowing lamp, and then climbed it himself, his own multimeter showing the same impossible reading. 0 volts. "This is not right," he muttered, more to himself than to me. "This is not how electricity works." We stood there for a long time, 2 experienced technicians, staring at a light that defied every rule we knew. The frost continued to melt from the lens, revealing the bare glass. The light now a steady, unwavering amber eye in the darkness. We discussed theories. Induction? A faulty meter? But both our meters were recently calibrated. A ground fault somehow creating a potential? But there was no ground fault indicator, and still 0 measurable voltage. The only remote possibility we could conjure was an extreme case of It would be an electrical anomaly of staggering proportions. My supervisor called security. "Check camera 3, he instructed. "Review footage from the east yard pole. say from 0030 to now. See if anyone approached the pole or if the light was on before the tag out. We waited, shivering, watching the light. The supervisor was already logging the incident, detailing the impossibility. "We can't work on this," he said finally. "The circuit is tagged dead, but the load is energized. It's a fundamental contradiction. It's unsafe to proceed." This was a professional protocol being abandoned. Not because it was wrong, but because the reality on the ground had broken the protocol itself. While we waited for the camera review, a distant freight train rumbled past the yard, its horn a mournful cry that seemed to emphasize the strangeness of the night. I thought about a summer evening years ago, sitting on my porch, watching fireflies flicker in the humid air. The streetlights coming on with a familiar, comforting click. That was how lights were supposed to work. Predictable. Security called back. Camera 3 footage reviewed. No personnel approached pole 7 between 0030 and 0115. The light was off at 0030. It came on sometime around 0040, slowly brightening, just as Unit 1 described. The light had come on after the tag out. It had energized itself. We ended up placing a perimeter around the pole, marking it as a hazard, and scheduling a full engineering review for the morning. We left the light burning, an impossible beacon in the frigid night. I removed my lockout tag from the main panel. Not because the circuit was safe, but because it was clear my tag had done nothing. It was still 0 volts at the pole, but the light was still on. I drove home as the first hint of dawn touched the horizon, leaving the glowing yard light behind. To this day, no definitive explanation was found. The light eventually went out on its own, sometime before noon the next day, without anyone touching it. The engineering report concluded it was an unquantifiable residual field effect, a vague term that offered no real answer. It was simply an event that defied the rules, a crack in the certainty I'd built my career on. And sometimes, on a cold, dark night, I still wonder what truly powered that light. The perimeter gate was an unforgiving place, especially on the graveyard shift. For 12 years I'd been a site guard, mostly overseeing industrial complexes and data centers. This particular facility, a sprawling logistics hub with critical infrastructure, demanded unwavering attention. My post was Gate Alpha, the primary vehicle entry point. It was a concrete bunker, bullet-resistant glass, and a console that could launch a small rocket, or at least it felt like it. The air conditioning hummed, a constant white noise against the distant drone of the city, and the occasional clatter of a freight train on the tracks a mile east. My tools were standard: a handheld scanner, a two-way radio, the digital logbook, and a .40 caliber on my hip. Every vehicle, every person, every package had to be accounted for. It was the bedrock of our security, a system designed to be impermeable. The clock on the console read 2:17. A light drizzle had started, tapping against the reinforced glass. My shift partner, Unit 2, was patrolling the north fence line, a 2-mile stretch that always seemed to attract wildlife, or sometimes less innocent curiosity. The night was quiet, the kind of quiet that usually meant trouble was brewing, or that I was just tired. I sipped lukewarm coffee from a thermos, The aroma of stale caffeine always seemed to cling to the guard shack air. A pair of headlights cut through the gloom down the approach lane. A standard white panel van, nothing unusual. It slowed, stopping precisely at the yellow line before the gate arm. I activated the intercom. "State your business and destination." A man's voice, clear, calm. "Delivery for control room. Scheduled maintenance check." I cross-referenced the manifest. Nothing for a scheduled maintenance check at 2:20. The system showed no appointments until 600. This was the first anomaly. My internal protocol flagged it. I leaned closer to the monitor. He was wearing a bright orange, high-visibility vest, the kind issued to contractors, and held a clipboard. He offered a small, polite smile, almost too perfect for the hour. "Please present your badge for scanning," I instructed, keeping my voice even. He held up a laminated ID card to the external reader. The green light flashed on the scanner. Good. The system processed the data. On my screen, the visitor management system populated a new entry. The photo matched the man in the van. The listed company was a legitimate vendor we used for HVAC and electrical work. So far, so normal. Then, the system threw a red flag. Visitor name not on approved rota for current shift. This was a critical alert. It meant the name on the badge, while valid in the system's database as a past visitor, wasn't cleared for this specific shift. It wasn't a "no record found" error, which would have triggered an immediate lockdown. It was a "record exists, but not authorized now." This usually indicated a scheduling error, a late addition to a team, or a forgotten update from the vendor. I'd seen it before. Often, a quick call to the control room or the vendor's dispatcher sorted it out. I was tired, my eyes a little gritty from staring at screens for hours. I made a mental note to confirm with the control room once he checked in. My mistake, a minor lapse in strict adherence, was to prioritize the immediate clearance over the deeper investigation. The badge scanned. The man smiled. I waved him through, telling him to report directly to the control room for full check-in, as per standard procedure for any visitor not explicitly pre-approved. The gate arm lifted with a hydraulic hiss. The van rolled forward, its taillights disappearing into the mist and the gloom of the yard lane. I logged the entry. 0221, panel van, vendor X, driver, badge name, destination, control room. Note, rota discrepancy, advised direct check-in. I took another sip of coffee. The hum of the AC felt louder now. A memory surfaced, unbidden. A summer afternoon, years ago, wearing a similar orange vest during a neighborhood park cleanup, the sun warm on my face, the simple satisfaction of community work. It felt very far from this cold, sterile shack. 20 minutes later, the internal phone rang. It was the control room supervisor. "Gate Alpha, this is Control. We have a question about a Vendor X maintenance team. You logged one in at 0221? "That's correct, Supervisor. Panel van, driver, badge name. Rota discrepancy, so I sent him straight to you for final clearance." A pause on the line. "Gate Alpha, no one from Vendor X is scheduled for maintenance tonight, and no one has reported to the control room. We've been monitoring the main entrance camera since 0200 lock. We have no record of any vehicle matching that description entering the yard." My blood went cold. "Supervisor, I have the entry logged. I scanned the badge. I saw the van. It's on my external camera feed right now, pulling away from the gate." I pulled up the gate camera feed. There was the van, turning left onto the main yard lane, heading towards the control room building. "Hold on, Gate Alpha. I'm checking the internal yard cameras now." Another pause. "Gate Alpha, I'm looking at yard camera 3, which covers that exact stretch of lane. At 0222, a panel van with similar markings does appear on screen. It proceeds for about 50 yards, then it just drives out of frame, past the old maintenance shed, and doesn't reappear on yard camera 4 or 5. It should have been visible for at least another minute before reaching the control room." "It's not possible," I murmured, my voice tight. "It's a straight shot. No turnoffs, no blind spots that large." "Gate Alpha, I'm telling you what the cameras show. The vehicle enters the lane, then it's gone. We're initiating a Code 2 search. You need to pull up that badge scan again. What was the name?" I pulled up the log entry. The system displayed the scanned badge information, a photo, a company, and a name. I spoke the name aloud. "Gate Alpha, that name. It doesn't exist in our system, not even as a past visitor. It's not in the Vendor X database either. I'm cross-referencing all personnel files. This name is completely unassigned." I stared at the screen, at the smiling face on the badge, the calm, almost serene expression, the high-visibility vest, the clipboard. I replayed my gate camera feed. The van pulling up, the man holding the badge to the reader, his polite, unnerving smile, the gate arm lifting, the van driving through, and then the internal cameras showing it simply ceasing to be. The Code 2 search yielded nothing. No panel van, no driver, no trace of anyone. The perimeter was secure, all fences intact, no other gate breaches. It was as if the van had simply dissolved into the mist of the yard lane after passing the maintenance shed. The badge itself, the digital record of its scan, became the focal point of the investigation. The supervisor confirmed that while the scanner registered a badge, the data it transmitted was a string of characters that, when parsed, pointed to a non-existent entry. A ghost in the machine. A phantom visitor. The smile in the badge photo, frozen in time on my screen, seemed to mock the entire system. It wasn't just a trespasser. It was an impossible one. A breach that left no physical evidence, only the chilling impression of a smile that passed through the gate and then vanished. I've been a night operator in these power substations for 17 years. Most of that time is spent in the quiet hum of transformers, monitoring the grid, logging data, and responding to the occasional fault. My shift starts at 2200, and by 300, the world outside has usually settled into its deepest sleep, and so has the demand on the system. The air is always cool in the control room, even in summer. A steady 68 degrees, and the only light comes from the glowing schematics on the meter wall and the work lamp on my desk. My tools are simple: a multimeter, a thermal camera, a logbook, and the radio. The job is about vigilance and knowing the system's heartbeat. Our primary substation, a sprawling complex of steel and ceramic insulators, handles the main feed for 3 counties. It's an old beast, upgraded in sections, but the core infrastructure dates back to the 50s. We had a sharp cold snap roll through last week, temperatures plummeting to single digits, putting a heavy strain on the heaters and furnaces across the service area. The system groaned, but held. Now, a few days later, the air was still crisp, but the demand had leveled out. Everything should have been settling. Around 3:15 I heard it. A faint, rhythmic sound, almost like a slow drip, coming from somewhere beyond the control room's insulated walls. My first thought was the old HVAC unit in the utility closet. It often made odd noises when the temperature shifted dramatically, metal contracting, ducts expanding. I logged it as ambient noise, probable HVAC, a minor detail, easily dismissed in the quiet monotony of the shift. I'd check it properly on my next rounds, after the 400 data pull. The rule, the absolute bedrock of this job, is that every significant event, every shift in load, every flicker of current, registers on the meter wall. The real-time plots, the digital readouts, they are the system's nervous system, reflecting its every pulse. If something is happening out in the yard, or in the breaker rows, it shows up here. That's the protocol. Physical observation confirms the data, and the data explains the physical. They are 2 sides of the same coin. At 03:45, the sound was clearer. Not a drip, but a distinct, metallic tick. Regular. 1 tick every 6 seconds, precise as a metronome. It was coming from the north breaker row, a long corridor of steel cabinets housing the high-voltage circuit breakers. I grabbed my thermal camera and the heavy steel keyring. The meter wall, specifically the plot for the north bus section, remained perfectly flat. No spikes, no dips, just the steady, unwavering line of normal load. This was the first contradiction. A physical anomaly without a corresponding digital footprint. I walked the 100 yards down the main hall, the sound growing louder with each step. The air in the breaker row was always cooler, a faint smell of ozone clinging to the steel. The sound led me to cabinet B12, a 138 kilovolt oil circuit breaker. It was an older model, a hulking gray box with a heavy latch and a large red handle. The ticking was originating from inside. I pressed my ear to the cold metal. Tick, tick, tick. It felt like the mechanism itself was counting down. I ran the thermal camera over the cabinet. No hot spots. The surface temperature was uniform, cool to the touch, consistent with the ambient temperature of the row. I checked the adjacent cabinets, B11 and B13. Nothing. Just the low hum of their operational status. B12, however, was clearly active in a way it shouldn't be. Then, I saw it. With each tick from inside the cabinet, the heavy red handle, designed to be locked firmly in place, twitched. A minuscule movement, maybe a millimeter, but undeniable. It wasn't enough to disengage the latch, but it was there. A subtle, almost imperceptible shudder against its resting position. I watched it for a full minute. The handle was trying to move. I radioed the supervisor. Operator to supervisor. Got an anomaly on B12, north row. Regular ticking, handle twitching. No load change on the meter wall. There was a pause. Repeat that, operator, No load change. Confirmed. Plot is flat. Thermal scan shows normal temps. Understood. Log it. Do not approach or attempt to operate the breaker. Secure the area and continue monitoring. I'll be in touch. The protocol for a physical anomaly on a high-voltage breaker is clear. Isolate, de-energize, inspect. But how do you isolate something that isn't showing up as active on the system? The meters were telling me B12 was doing nothing out of the ordinary. Yet it was physically ticking and twitching. The protocol demanded a load change to justify a full shutdown procedure. Without it, I was in a gray area, told simply to monitor. It felt like being asked to treat a broken bone that the X-ray insisted was perfectly fine. I walked the length of the bus run, checking the connections, the insulators, looking for any other physical sign of stress. The air was still, the smell of ozone constant. I remembered a time, years ago, when I was home trying to fix a persistent drip under the kitchen sink. A simple washer replacement, a straightforward problem with a clear solution. This was different. This was a problem that refused to acknowledge its own existence. I returned to B12. The ticking continued, relentless. I stood there, watching the handle twitch. The meter wall 100 feet away displaying its serene, unchanging data. It was as if the breaker was operating on a different timeline, following a different set of rules. The cold snap had come and gone, but something in that heavy steel box was still reacting, contracting, expanding, remembering the stress long after the system had forgotten it. The thermal memory creep, a phantom limb of the grid, manifesting as a physical tick. I logged the event again, noting the exact time of each observation. B12, 0418. Rhythmic tick, handle twitch. Meter wall, 0418, no change. The contradiction was stark. I stayed in the breaker row, my hand on the cold steel of a support beam, feeling the faint condensation on its surface. The tick continued. The system was stable, the supervisor was aware, but the breaker was telling a different story. A private, mechanical rhythm unheard by the digital world. I knew I wouldn't be leaving the North Breaker row until sunrise. I've logged over 15 years as a control room lead for the regional utility grid, overseeing the intricate dance of power distribution across 3 states. My domain is a windowless chamber in our northwestern facility, a symphony of low-frequency hums, blinking LEDs, and the crisp, precise click of console buttons. My station, Console Bay 3, is a custom-built unit, designed for optimal ergonomic access to multiple comms channels, grid schematics, and weather feeds. We pride ourselves on system integrity, on the absolute clarity of our signals and the discipline of our comms protocols. A muted channel, by definition, is silent. It's a deadline, a blank slate, awaiting activation. This understanding is foundational to our operation. The night shift had settled into its predictable rhythm. Outside, a steady, cold rain lashed against the building's reinforced concrete, a sound barely audible over the constant, deep thrum of the server racks in the adjacent room. I was reviewing a substation power draw anomaly, a minor fluctuation that required a log entry, but no immediate action. My left hand rested on the comms panel, fingers brushing the smooth, cool plastic of the channel mute buttons. My primary operational channel, linking me to field units, was active, but currently silent. The secondary channels, used for interfacility comms and emergency backup, were all muted, their small amber indicators glowing steadily. It was then a subtle intrusion, almost imperceptible against the background hum. A soft, shallow intake of breath. It wasn't a static pop, nor the distant crackle of a faulty line. It was organic, a living sound, barely audible, yet distinct. My head snapped up from the screen. I checked the active channel's audio meter. Flat. No incoming audio. I scanned the physical room, my eyes sweeping past the empty console Bay 2 and the sleeping form of the junior operator at Bay 1, head resting on his folded arms. The room was still. I exhaled slowly, a quiet sigh of fatigue, and the sound came again, a beat late, from the speaker of my primary comms channel. A soft, distinct exhalation. My own. My brows furrowed. This was impossible. The channel was active, yes, but no field unit was transmitting. My desk mic was hot, indicated by a small green LED, but I hadn't pressed the transmit button. The mic was designed to be highly directional, not to pick up ambient room noise, and certainly not to feed it back into the speaker. I initially dismissed it as an auditory illusion, a trick of tired ears. I'd been on shift for 10 hours, and the rain outside combined with the low hum could create strange acoustic effects. It was a minor mistake, a brief lapse in my usual analytical rigor. I rubbed my eyes, convinced it was just a phantom sound. To test it, I leaned forward, bringing my mouth closer to the desk mic, and took a slow, deliberate breath in, then out. The speaker responded, a quiet intake, then a soft exhale, mirroring my own, a fraction of a second behind. The sound was too precise, too perfectly aligned with my own breathing to be coincidence. It was my breath. But how? The channel was receiving, not transmitting. I pressed the mute button on the primary channel. The amber light clicked on. The speaker went dead silent. I breathed again, intentionally. Nothing. Good. That's how it should be. Then, a new dread began to form. From the now muted primary channel, a soft, shallow intake of breath. And then, a quiet exhalation. My breath, still. Still a beat late. Still on a muted channel. My heart gave a sharp, unpleasant thump. This violated every principle of comms integrity. A muted channel should carry nothing. I leaned back in my chair, away from the console, my hands hovering over the keyboard. The breath from the speaker died. The silence was absolute. I leaned forward again, sitting upright, my posture returning to the standard operating position. The soft, delayed in, out. It was a perfect echo, a ghost of my own respiration, appearing on a channel that should have been acoustically sealed. I reached for the patch panel, located beneath the main comms console. This was a critical piece of hardware, allowing us to reroute audio lines, isolate faults, and bypass damaged circuits. My protocol for any unexplained audio anomaly was to systematically trace the signal path. I pulled out a small, coiled patch cable. The patch panel itself was cold to the touch, its rows of jacks glinting under the console's task light. I remembered a time, years ago, when a field unit had reported a persistent, high-pitched whine on their comms. I'd spent an entire shift methodically patching and testing, eventually tracing it to a faulty ground loop in a remote repeater. It had been a satisfying, logical puzzle. This felt different. I began by patching the primary comms output to an auxiliary diagnostic port, bypassing the internal console speaker. I put on my headset, hoping to isolate the source more clearly. The breath persisted in the headset's earpiece. It was clearer now, almost intimate, as if someone was breathing directly into my ear. I disconnected the desk mic entirely, pulling its XLR cable from the console. The green LED went out. I breathed. The breath from the headset continued. A soft, rhythmic presence. This was impossible. The input was physically disconnected. I stood up, walked around the console, and peered at the back of the unit, checking all connections. Everything was seated correctly. No loose cables, no visible damage. I walked to the edge of the console bay, taking 2 steps back. The breath in the headset stopped. I took 2 steps forward, returning to my seat. The breath resumed. It was tied to my physical presence at the console, yet it was emanating from a channel that was muted, disconnected, and supposedly silent. I tried another approach. I patched the primary comms output directly to an external audio analyzer. The analyzer's display, a small LCD screen, showed a faint, oscillating waveform, perfectly matching the frequency and amplitude of a human breath. It was real. It wasn't in my head. But the analyzer's input was directly from a muted, disconnected channel. There was no logical path for this signal. The comms integrity protocol, the very foundation of my work, offered no explanation, no diagnostic tree for a sound that originated from nowhere and mirrored my own biological functions. It was a failure of the system, not a technical glitch, but a fundamental breakdown of what I understood about physics and electronics. The junior operator stirred, groaning softly. I considered waking him, asking him to listen. But what would I say? My muted comms channel is breathing my breath back at me? It sounded like a fever dream. The rain outside had picked up, drumming a relentless rhythm against the roof. I tasted the metallic tang of old coffee in my mouth, a stark contrast to the clean, sterile scent of ozone that usually permeated the control room. I sat there, frozen, listening to the impossible echo of my own breath. It wasn't malicious, not overtly threatening, but deeply unsettling. It was a violation of privacy, a phantom presence that stole a piece of my unconscious self and played it back. As the shift drew to a close and the day operator arrived, I logged the anomaly under undetermined audio interference, primary comms channel. I described the symptoms precisely, omitting my personal involvement in the mirroring. The day operator, a seasoned veteran, simply nodded, his face unreadable. He'd seen stranger things, perhaps. As I walked out into the pre-dawn light, the rain finally easing, I found myself holding my breath, listening for an echo that wasn't there. The control room had always been a place of order and predictable systems. Now, it held a secret, a quiet, impossible presence that breathed a beat behind me, waiting for my return. My shifts often start before the sun clears the eastern ridge, especially for perimeter checks. I've been a maintenance hand for this facility for 17 years, covering everything from HVAC units to the miles of chain link that define our property line. I know the ground, the quirks of the old electrical systems, the way the wind funnels through the canyons. My primary tools are a multimeter, a good pair of pliers, and an unshakable trust in what my instruments tell me. This particular morning, the assignment was routine. Inspect the south fence line. A recent microburst had been reported, and while no structural damage was visible from aerial scans, ground-level assessment was required. I parked the utility vehicle at the designated access point on the gravel path, about a quarter mile from the section I needed to examine. The air was still, cool, with a faint, almost sweet scent of dry pine needles heating in the early sun. It was the kind of quiet morning that usually meant an easy day. I grabbed my kit, flagging tape, a few zip ties, a small handheld anemometer, and the facility's standard warning stanchion. The stanchion was a bright yellow plastic tripod, designed to hold caution tape and alert personnel to a work zone. Protocol dictates that for any fence repair, a perimeter must be established at least 10 feet out from the work area. This keeps incidental traffic clear and provides a buffer for any unexpected hazards. I walked the south fence line, scanning for loose wires, bent posts, or compromised footings. Everything looked solid. The main facility wind vane, visible atop the central administration building, indicated a steady breeze from the northwest, about 5 knots. My handheld anemometer, which I always double-check against the main vane, confirmed this reading. A perfect, predictable morning. I reached the section marked for closer inspection. There was no visible damage, but the work order was explicit. I decided to replace a few older zip ties on a gate latch, just to be thorough. I set up the warning stanchion on the gravel path, roughly 15 feet from the fence, and began to unspool a fresh roll of bright yellow caution tape. The tape was new, crisp, a standard 2-inch width, marked with repeating, "Caution, do not enter," in bold black lettering. I secured one end to the stanchion and started walking parallel to the fence, letting the tape unroll behind me. As I reached the midpoint of the intended perimeter, about 30 feet from the stanchion, I felt a peculiar tug. Not the usual resistance of the roll, but a distinct pull, sideways. I glanced back. The section of tape I'd just unspooled, still connected to the roll in my hand and anchored to the stanchion, was not just hanging loose. It was lifting, bowing inward towards the chain-link fence. It looked like a thin yellow kite straining against an invisible string. My first thought was a localized gust, an eddy I hadn't registered. But the air around me was still. My anemometer, clipped to my belt, read 0. I looked up at the main facility wind vane. It remained stubbornly locked on northwest, steady as a rock. The tape, however, was clearly pulling east, directly towards the fence. I stopped unwinding. The tape, perhaps 10 feet of it, was now fully aloft, taut, vibrating slightly. It wasn't fluttering, it was drawn, as if a hand was tugging it from the other side of the fence. I took a step back, my boots crunching on the loose gravel. This wasn't right. Wind doesn't pick up a single section of tape and hold it steady against a fence line while the rest of the air is calm. I walked back to the stanchion, reeling in the tape slightly. The tension was palpable. When I released the tape, it immediately sprang back, lifting and pulling again. I tried to dismiss it as an odd static charge. Something perhaps built up in the new plastic. I've seen that before, especially with certain synthetic materials in dry conditions. But this was more than a cling. It was an active, sustained draw. I pulled out my multimeter, set it to measure voltage, and carefully approached the fence. Nothing. The fence was a passive barrier, no current running through it. I swept the meter over the tape itself. Still nothing. The readings were flatline. My initial assessment, that this was just a static charge, was proving difficult to confirm with my tools. It was a minor mistake, assuming a common phenomenon without checking, but the instruments were giving me no help. I decided to try an experiment. I cut a 2-foot section of the caution tape. I held it out, then released it. Instead of drifting to the ground or blowing with the indicated northwest wind, it floated. Slowly, deliberately, it drifted east, straight towards the fence. It didn't stick immediately, but hovered a few inches from the wire mesh, then settled gently onto it, adhering perfectly flat, as if pressed there. I tried again with a small dry leaf I picked from the ground. The leaf fell normally, landing on the gravel path. The wind vane still read northwest. I felt a prickle on my skin, a faint tingle, like the air itself was charged. I remembered a time, years ago, when I was a kid flying a cheap plastic kite in a field near a power substation. The string had gone slack, then suddenly taut, pulling the kite towards the humming lines, even though the wind was blowing the other way. My dad had yanked it down, warning me about invisible forces. This felt similar, but without the hum, without the visible power lines. I called dispatch. Unit 1 to control. I'm on the south fence line, section Delta 7, experiencing an anomalous condition. Go ahead, Unit 1, came the calm voice of the dispatcher. I have caution tape being drawn to the fence line against prevailing wind direction. No measurable electrical field, no visible cause. Wind vane reads northwest, but tape is pulling east. There was a pause. Unit 1, confirm your instruments are functioning. Confirmed, Control. Anemometer reads 0 where I am. Main vane reads northwest. Tape is actively pulling. Understood, Unit 1. Stand by. I'm alerting a supervisor. While I waited, I tried to pull the tape off the fence. It was stuck fast, not with adhesive, but with an invisible grip. It felt almost like a strong vacuum seal. I had to peel it off with effort, leaving behind a faint, almost iridescent residue on the galvanized wire. This wasn't an ordinary static cling. It was beyond the scope of any protocol I knew for securing a perimeter. The protocol of establishing a clear, safe exclusion zone was failing, because the very material meant to define that zone was being pulled into the hazard. Minutes later, the supervisor arrived in his own utility vehicle, gravel crunching as he pulled up. He was a practical man, by the book. I explained the situation, gesturing towards the section of tape I'd managed to resecure to the stanchion, which was still bowing inward, taut as a bowstring. He pulled out his own handheld anemometer. Reads calm here, he said, confirming mine. He looked at the main wind vane. Northwest, steady. And you're saying this tape? He reached out, touching the yellow plastic. He paused, his brow furrowed. It's tight. It's pulling, I reiterated, like something's tugging it from the other side. He walked the fence line, looking for any possible source. A hidden fan, an exhaust vent, anything. There was nothing. Just the chain link, the dry grass, and the gravel path. He tried his own multimeter, sweeping it along the fence and the tape. His readings were identical to mine, flatline. This is unusual, he finally said, his voice clipped. I'm going to log this as an unknown atmospheric condition. We'll secure the area with heavier barricades, not tape. He was abandoning the standard tape protocol. The yellow kite, still straining towards the fence, was an impossible contradiction. The wind vane, still pointing northwest, mocked the visible reality. We cordoned off the section with heavy concrete barriers, a clear admission that our usual methods were insufficient, that something unseen was at play. As we drove away, I looked back. The thin yellow tape, still attached to its stanchion, was still pulled taut, a silent, impossible banner against the unmoving fence. I've been a substation supervisor for 15 years, overseeing the critical infrastructure that keeps power flowing across a sprawling rural district. My territory covers everything from high-voltage transmission lines to the local distribution points, a network of steel, copper, and finely tuned electronics. It's a job built on predictability, on the absolute adherence to established protocols, and on the unwavering belief in the data delivered by our instruments. My daily routine involves walking the grounds, listening to the rhythmic hum of transformers, checking gauges, and performing visual inspections of every cabinet, every breaker, every bus bar. The air in a substation always carries a faint scent of ozone and clean, dry metal, a smell that becomes as familiar as your own home. One Tuesday in late spring, the air was still and warm, promising a hot summer ahead. I was on my routine inspection through the main relay room, a cavernous space filled with rows of metal cabinets, each housing the sensitive relays and controls that manage the flow of electricity. The room itself is climate-controlled, kept at a steady 70 degrees Fahrenheit, ensuring optimal operating conditions for the electronics. As I moved down aisle 2, my hand brushing against the cool, painted steel of the cabinet doors, I paused at cabinet 7B. It was a standard 1960s-era unit, housing a bank of protective relays for a key distribution feeder. My fingers registered an unexpected warmth. Not hot, not alarming, but distinctly above ambient. I pulled my hand back, then placed it against the door again. Yes, definitely warm. A faint, almost imperceptible smell drifted from the seams of the door, like hot dust, the kind you get when an old space heater kicks on after months of disuse. My first thought was the heater strip. Every cabinet contains a small resistance heater, thermostatically controlled, designed to prevent condensation in colder months. But it was May, well past the season for condensation. I consulted the local thermostat dial on the cabinet's side. It was set to off. I double-checked the breaker for the heater circuit in the adjacent panel, also in the off position. The system was clearly idle. This was an anomaly. Standard procedure dictates that any unexpected heat source is investigated immediately. I pulled my thermal imaging gun from my belt holster. This Fluke 62 Max Plus is a reliable tool, capable of detecting even subtle temperature differentials. I aimed it at the cabinet door. The digital readout on the screen remained stubbornly consistent. 70.2 degrees Fahrenheit, 70.1 degrees Fahrenheit, 70.3 degrees Fahrenheit. Precisely ambient. I scanned the entire door, then the adjacent cabinets for comparison. All read within 1/10 of a degree of the room's set temperature. My hand still felt the warmth, a sensation that seemed to defy the instrument. I remember thinking, maybe my hand is just cold from holding the metal railing, creating a phantom sensation. It was a small, almost unconscious dismissal. A minor lapse in my usual rigor, but enough to make me log the incident simply as Cabinet 7B, heater strip anomaly, no thermal signature. Recheck later. I moved on, the faint smell of hot dust lingering in my mind. The next morning, the memory of the warm door nagged at me. After my initial rounds, I made a point of returning to aisle 2. The relay room was quiet, the usual low hum from the transformers a steady drone. I approached Cabinet 7B. As I neared it, the smell of hot dust was more pronounced. A dry, slightly acrid scent that seemed to emanate directly from the cabinet. I placed my palm against the door. The warmth was undeniable now, a distinct contrast to the cool metal surrounding it. It felt like a low-wattage light bulb was glowing just beneath the surface. I pulled out the thermal gun again. I scanned the door, the hinges, the top, the bottom. My hand felt a temperature significantly higher than 70 degrees, yet the gun insisted otherwise. I even tried a different angle, thinking perhaps the angle of incidence was off. No change. This was no longer a minor anomaly. My primary diagnostic tool, designed specifically for this purpose, was contradicting my direct sensory input. This was a violation of a core principle. Instruments don't lie. But neither did my hand, nor my nose. I radioed for Supervisor Miller, who was on duty in the adjacent control room. "Could you come take a look at something in the relay room?" I asked, keeping my tone neutral. When Miller arrived, I led him to Cabinet 7B. "Feel this," I said, placing his hand on the door. He frowned, his brow furrowing. "Huh, yeah. That's definitely warm. What's going on?" I explained the situation. The idle heater, the off-breaker, the thermal gun's uncooperative readings. He took his own thermal gun from his belt. His Fluke 62 Max Plus, identical to mine, also read ambient. "That's strange," Miller said, shaking his head. "Never seen anything like it. Heat you can feel, but the gun says no." We decided to open the cabinet. This was a more involved procedure. We initiated a lockout-tagout on the feeder, ensuring no power could accidentally flow to the relays inside. We donned our arc flash suits and gloves, following the strict safety protocols for working on energized equipment, even though our intent was only visual inspection. The air inside the substation always felt a little heavier when suited up. The hum of the transformers a distant thrum through the hood. I remember once, as a kid, trying to fix a broken toy car with my grandfather, feeling the same intensity of focus, the same sense of careful precision, but without the underlying hum of thousands of volts. With the door unlatched, the smell of hot dust intensified, a dry, cloying odor. We swung the heavy metal door open. Inside, everything appeared normal. The relays were cool to the touch. The wiring was neat, orderly, with no signs of scorching, discoloration, or arcing. I ran my gloved hand along the heater strip at the bottom of the cabinet. It was cool. I checked the wiring connections to the strip. All tight, no obvious faults. Yet, the warmth persisted. It wasn't coming from any specific component. It felt diffuse, as if the very air inside the cabinet was warmer than the room, even though it was now open to the room's controlled temperature. We used our thermal guns inside the cabinet. Still, nothing. Ambient. We couldn't pinpoint a source. It was as if the heat existed in a pocket, a localized thermal anomaly that our instruments simply refused to acknowledge. We spent another hour systematically checking every component, every connection, every possible source of resistive heat. We even used a multimeter to check for any phantom voltage on the heater strip wiring, ruling out a ground fault. Nothing. Every test yielded a negative result, yet the warmth remained, a stubborn, unexplainable phenomenon. A small, delicate spiderweb, shimmering with condensation, hung in the corner of an adjacent, unrelated cabinet, completely oblivious to our growing frustration. Finally, Supervisor Miller sighed. "This is a first for me. All protocols followed, all diagnostics run, and nothing. It's a ghost load." He meant a load that drew power and generated heat, but couldn't be found or measured. Except in this case, it wasn't drawing power, as far as we could tell. We closed and relatched the cabinet door, securing the lockout-tagout, leaving the feeder de-energized. We logged the incident as unexplained thermal anomaly, cabinet 7B. No electrical fault detected. All instruments read ambient. Tactile warmth and hot dust smell persist. Further investigation pending. That was weeks ago. Cabinet 7B remains de-energized, taken out of service. Every time I walk past aisle 2, I instinctively reach out and touch the door. It's still warm. The smell of hot dust still occasionally drifts from its seams. Our instruments, our reliable, trusted tools continue to read ambient. It's a constant, unsettling reminder that sometimes, even in the most predictable and controlled environments, some things just defy explanation. The rules of physics, it seems, can bend in the most unexpected places. I've been a troubleshooter for 15 years, specializing in high-voltage substations and transmission lines across the upper Midwest. My certifications cover everything from switching procedures to emergency fault isolation. You learn to read the weather, the hum of transformers, the subtle shifts in a system that tell you something's off long before an alarm goes. Most of my work is preventative, checking thermal scans, tightening connections, clearing vegetation. But when a storm rolls through, especially freezing rain, the job shifts to reactive. Ice is an insulator, but it can also bridge gaps, creating unexpected conductive paths. This particular night, the sleet had been coming down for hours. It was a late shift, past 0300, and the substation near the old rail yard was my last stop. The air was heavy, the kind of wet cold that seeps into your bones no matter how many layers you wear. My truck's heater was struggling. I pulled on my insulated coveralls, hard hat, and face shield, grabbed my IR camera and a hot stick, and started my walk down. The procedure was standard. Visual inspection for ice buildup on insulators, conductors, and disconnects. Then a thermal scan of the major components, transformers, breakers, the main bus bar run. The crunch of ice under my boots was the only sound besides the steady hiss of the sleet and the low thrum of the 138 kilovolt bus. My headlamp cut through the swirling flakes, reflecting off the glazed steel structures. I was halfway through the inspection, checking the integrity of the main rail line that fed the primary transformer, when it happened. A brief, vivid blue wash bloomed across the rail, maybe 20 feet ahead of me. It wasn't a flash, not a crack of lightning, but a silent, liquid light that seemed to walk along the top of the steel for perhaps a second and a half. It had a distinct, almost organic quality, like something alive tracing a path. Then, as suddenly as it appeared, it cut itself short, vanishing without a sound, leaving only the darkness and the sleet. My first thought was a fault. An arc of that intensity, even a brief one, should have tripped a breaker somewhere. I instinctively pulled out my tablet, my fingers fumbling slightly in the cold, and brought up the SCADA system logs. I refreshed the screen, checked the fault indicators, the current readings, the historical data for the last 5 minutes. Nothing. No trips logged, no voltage dips. The system reported nominal operation across the entire substation. It was as if the blue light had never existed. But it had. I could still smell the sharp metallic tang of ozone in the air, faint but unmistakable. And where the blue wash had vanished, directly on the gravel beneath the rail, a small patch of steam rose, dissipating quickly into the freezing air. The gravel was visibly darker, wetter, briefly superheated. My mind, tired from the long shift and the cold, tried to reconcile the contradiction. My mistake was not immediately calling dispatch to cross-reference their SCADA, instead trusting my own tablet and the assumption it might have been an optical illusion or a distant atmospheric event. I walked to the spot, my boots crunching through the fresh ice. The steaming patch was gone, but the gravel was still damp, a dark stain against the lighter, frozen aggregate. I knelt, shining my headlamp directly on the rail. No carbon track, no pitting, no physical evidence of an electrical discharge. The steel was smooth, coated in a fresh layer of ice. This was beyond unusual. An arc, especially one that could generate enough heat to steam gravel, always leaves a mark. It always trips a breaker. That's the fundamental rule of high-voltage systems. Protection. I called dispatch. Unit 2 to control. I observed a transient arc on the main rail line, near the primary transformer. Visual confirmation, but no fault indication on SCADA. Can you confirm no trips? The voice on the other end was calm, professional. Negative, Unit 2. All systems nominal here. No alarms, no trips. Are you reporting a visual error? Negative, I repeated, my voice tight. Definitely saw it. And there's residual heat evidence on the ground. Understood. Proceed with caution. Log as observed anomaly. Continue inspection. I continued, but my focus had shifted. I moved slowly, scanning the bus bar run with my IR camera. All temperatures were within spec. The sleet continued its relentless descent, coating everything in a fresh, transparent glaze. The constant drip-drip of melting ice from a nearby overhead light fixture echoed oddly in the quiet substation. A tiny, irrelevant sound in the vast, cold space. I found myself thinking about a warm mug of coffee back at the office. The simple comfort of a dry, heated garage after a long, wet job. The thought was a brief, welcome distraction from the growing unease. My standard protocol dictated that if a transient arc was observed, I should immediately isolate the affected section, if possible, and conduct a thorough visual inspection for potential ice bridging or insulation breakdown. But with no trip, no fault, and no visible damage, there was no affected section to isolate. The system was telling me everything was fine. My eyes and the steaming gravel told me otherwise. I moved into the knife switch bay, a maze of open-air disconnects and buswork. Ice was accumulating here, bridging some of the smaller gaps between non-energized components, but nothing that would cause a flashover on the main rail. I was examining a particularly heavy buildup on a vertical disconnect, shining my light into the intricate connections when I felt it. A faint vibration, a low hum that wasn't part of the substation's normal chorus. It seemed to come from below, from the concrete floor. Then, a flicker. Not the blue wash this time, but a softer, almost internal glow, emanating from within the ice buildup on a set of parallel bus bars, deep in the knife switch bay. It was like watching static electricity play across a surface, only silent, contained. It lasted only a fraction of a second, a pulse of light that seemed to travel horizontally along the ice-covered conductors, then winked out. Again, no sound, no trip, no visible damage when I quickly scanned the area with my IR camera. The ice remained intact. This was a different kind of arc, a ghost arc. It moved, not through the air but through the ice. The natural ice arc was a known phenomenon, but it usually resulted in a catastrophic flashover and a trip. This was something else. It was moving, not towards a fault but seemingly with its own purpose. My professional protocol was failing me. How do you address an electrical event that leaves no trace and trips no protective relays? I followed the direction I'd perceived the second flicker to move. A hunch, more than a logical deduction. It led me to the edge of the knife switch bay, towards the perimeter fence, and the concrete drain trench that ran along it. The trench was designed to collect rainwater and snowmelt, directing it away from the sensitive equipment. It was half filled with icy water, a black, reflecting surface under my headlamp. As I approached, I saw it. A faint shimmer, a disturbance on the surface of the water in the trench. And then, a small, localized cloud of steam rose, just like the gravel earlier. This time, there was a barely audible hiss, quickly swallowed by the sleet. The water in that small section of the trench was steaming. An arc, or something that behaved like one, had traveled from the main rail, through the knife switch bay, and into the drain trench. It had walked. I stood there, the sleet plastering my face shield, staring at the steaming water. My training, my experience, my certifications, none of it offered an explanation. An electrical arc, even one caused by ice, follows the path of least resistance to ground, or between phases. It doesn't walk along a rail, then through a complex bay, and finally into a drain trench, leaving no physical evidence and no record on the system. The system was supposed to know. It was supposed to protect. It was supposed to trip. I spent another hour meticulously inspecting the entire substation. I checked every insulator, every conductor, every bus bar with my IR camera. I found nothing. No hotspots, no tracking, no signs of a flashover. The sleet continued to fall, slowly burying any remaining evidence. My log entry was brief, factual, and utterly insufficient. 0345-0500. Substation 11B inspection. Observed 2 transient arc events, first on main rail, second in knife switch bay, both without fault indication. Localized steaming observed at both points and subsequently in drain trench. No physical damage or system anomalies detected. All parameters nominal. I drove out of the substation, the sleet still falling, the orange glow of the mercury vapor lamps fading in my rearview mirror. The system was fine. The power was flowing, but something had walked the rail, and the system hadn't even noticed. I've been a systems tech for nearly 20 years, specializing in industrial surveillance and access control. My work mostly involves maintaining the digital eyes and ears of large facilities, warehouses, distribution centers, manufacturing plants. I'm based out of the Pacific Northwest, covering a 3-county area, and I'm certified on most major IP camera platforms and network video recorders. My toolkit is an extension of my arm. Laptop, network tester, crimpers, a pocket full of RJ45s, and a healthy dose of skepticism for any reported anomaly. Systems are logical. Glitches usually trace back to power, cable, or configuration. That's the rule. A Tuesday morning started like any other. The air was crisp, smelling faintly of pine and diesel from the nearby highway. I was halfway through my first coffee, reviewing network health reports from my desk in the maintenance office, when the internal line buzzed. It was the security supervisor from the main gate. "Tech," the supervisor said, his voice tight. "We've got a problem with Gate 1's dome cam. The live feed is showing a truck at the outbound lane, but it cleared the yard an hour ago. We logged its departure at 06:15. I pulled up the feed on my primary monitor. Gate 1. It was a standard 4K PTZ dome, mounted high on a steel pole, overlooking the main exit lane and the adjacent guard shack. Sure enough, a Class 8 semi-trailer, dark blue, was positioned perfectly in the outbound lane. Its trailer was a plain white box. The time overlay in the bottom left corner of the screen read 07:28:41. The timestamp was advancing smoothly, second by second. "Okay, I see it," I replied, already running preliminary diagnostics. Network connection looks stable. Camera reports normal operation. No packet loss. My initial thought was a stuck frame, a common issue with older codecs or overloaded network segments. But the time bar was moving. That usually meant the stream was live. "Is the image frozen or is it looping?" "Neither really," the supervisor said, sounding confused. "It just is. The exhaust plume from the truck's stack. It's hanging perfectly still in the air, like a photograph. But the clock keeps ticking." I zoomed in slightly. He was right. The faint gray haze of diesel exhaust, typical on a cold morning, was unnaturally static. It defied the slight breeze I knew was blowing outside. This was beyond a simple network hiccup. My core protocol, the one I relied on, stated, "What the camera sees, the system records, in real time with an accurate timestamp." This image was violating that fundamental principle. I opened a remote shell to the camera's internal web interface. All sensor data looked nominal. Temperature, voltage, network throughput, everything within spec. I checked the firmware version. It was current. I navigated to the live stream configuration, toggled the resolution down, then back up, hoping to force a reinitialization of the video pipeline. The screen flickered once, then the truck reappeared. Exhaust plume frozen, time still advancing from 7:29:15. "I'm not getting a clean refresh," I told the supervisor. "I'm coming out there. Check the NVR for me, see what it recorded for that specific time frame, 6:15 to 7:30. The drive to the gate was short, less than a quarter mile. The air was noticeably colder than it had been in the office, a damp chill that promised rain. As I approached the guard lane, I saw it with my own eyes. The outbound lane was empty. Not a trace of a blue semi. The tarmac was clean, a few leaves skittering across it in the breeze. I parked and walked into the guard shack. The supervisor had the NVR interface pulled up on a dedicated monitor. "Here," he said, pointing. 6:15, truck clears the gate. 6:16, lane is empty. Then, around 6:30, it just appears again on the live feed. And the NVR recorded it. He clicked to play back the recorded footage from 7:28. On the screen, the blue truck sat, Exhaust plume static, the time bar rolling forward, perfectly synchronized with the live feed I'd seen in my office. The NVR, the central recording device, was faithfully archiving this impossible image. "This is impossible," I muttered, my voice flat. The NVR's internal clock was synchronized with NTP servers, accurate to milliseconds. The camera's clock was also synchronized. There was no drift. I pulled out my laptop, connected it to the guard shack's network jack, and ran a direct diagnostic on the camera's IP address. I bypassed the NVR, accessing the raw stream and the camera's internal persisted frame buffer. The buffer, by design, should hold only the most recent frames, constantly overwriting older data. Yet, it was spitting out the same image. "I'm going to the pole," I announced, grabbing my tool bag. "I need to physically inspect the unit." The camera pole stood maybe 30 feet high, a sturdy galvanized steel mast. I pulled on my lineman's gloves and clipped my safety harness. The smell of damp earth and decaying leaves was strong here, a scent I always associated with autumn. I remember once, as a kid, climbing an old oak tree in my backyard, the rough bark against my hands, the world looking different from up high. That memory felt distant, almost alien, compared to the cold precision of the equipment I was about to work on. I ascended the pole, the metal cold against my boots. At the top, I unlatched the dome housing. The internal components were pristine, no signs of moisture intrusion or insect nests. I connected my laptop directly to the camera's service port. This connection bypassed the entire network, talking directly to the camera's processor. I ran a deep diagnostic. The camera reported its internal clock was correct. Its sensor was reporting light levels consistent with the current environment. Its internal diagnostics showed healthy processing and memory usage. Yet, the live preview on my laptop, piped directly from the camera's sensor, showed the blue truck. I tried a hard power cycle. I disconnected the PoE injector, waited 30 seconds, then reconnected it. The camera went dark. I watched the status lights on my network tester cycle through their boot sequence. Green, then amber, then solid green. The camera came back online. The live preview on my laptop, the one directly from the camera's service port, showed the empty lane for a brief, glorious second. Just an empty, gray stretch of asphalt. Then, with a subtle pop on the audio feed from the guard shack, the image snapped back. The blue truck was there again, exhaust plume still. The time bar on my laptop screen advancing from 07:58:12. "It's still there," the supervisor's voice crackled over my radio. The truck, on the NVR feed. My heart hammered. This wasn't a network issue, not a corrupted file, not even a faulty sensor. The camera was physically sound, functionally active, yet it was broadcasting an image from the past. It wasn't looping. It was persisting a moment that had already occurred, presenting it as the present. I checked the camera's internal log. No errors, no reboots, just a continuous stream of normal operation entries. I descended the pole, the cold metal biting through my gloves. My initial mistake had been not questioning the premise more deeply, assuming a simple technical fault. I had wasted time on standard troubleshooting, dismissing the supervisor's precise description of the frozen exhaust plume. This wasn't a standard fault. Back in the guard shack, I pulled up the NVR's event log. The system had recorded the truck's departure at 06:15. Then, starting at 06:30, it recorded the truck's reappearance and its continuous presence for every minute thereafter. The system was performing its function perfectly, recording what it was being fed. But what it was being fed was a lie. I had to abandon the usual protocol of fixing the issue. There was nothing to fix. The camera was working perfectly, just not in this reality. I wrote up a report, detailing every step, every diagnostic, every contradiction. I recommended replacing the camera, but I knew, deep down, it wouldn't solve anything. It wasn't the camera that was broken. It was the moment it had captured, somehow detached from the flow of time and stubbornly insisting on its own existence. The supervisor just stared at the screen, the blue truck idly waiting at a gate it had left hours ago, the exhaust hanging in the still digital air, the time bar rolling smoothly into a future that the camera had already seen. For 12 years, I've worked as a shift lead in various industrial facilities, mostly in the Pacific Northwest. My current post is at a materials processing plant, a sprawling complex of concrete and corrugated steel nestled against a dense timberline. It's a 24/7 operation, and I'm usually on the graveyard shift, overseeing the flow of raw product from the yard to the initial sorting lines. My station is the control desk, a sturdy laminate counter packed with monitors, communication gear, and the ever-present logbook. To my right, mounted on a steel panel, is the key rack. To my left, the yard radio. The key rack is a vital piece of equipment. Each hook holds a heavy steel ring, each ring laden with a dozen or more keys for specific gates, utility sheds, and equipment lockers across the property. There are 22 sets in total, each tagged and numbered. The protocol is strict. Keys are signed out, signed back in. No exceptions. They represent access, and therefore security. When a set is returned, the metallic clatter as it hits the hook is a familiar, reassuring sound, a sign of order maintained. It was just past 200 hours on a Tuesday, a night like any other. The air outside was cold and still, a faint scent of damp earth and pine needles filtering through the ventilation system. Inside, the control room hummed with the steady thrum of the server rack behind me, and the low murmur of the processing lines 100 yards distant. I was reviewing the last hour's output data, a task that required concentration but often blurred into a quiet rhythm. My attention was momentarily diverted by the yard radio, which crackled to life. Unit 3 was calling in a routine status update from the north perimeter. Control, Unit 3, North Gate secure, all clear. The voice of the patrol officer was clear, if a little distorted by the radio's speaker. Roger that, Unit 3. Maintain patrol, I replied, keying the mic. As the carrier tone of the radio transmission faded, a soft, metallic chime echoed from the key rack. It was distinct, a clear, ringing sound, like a miniature bell. I looked up immediately. No one was near the rack. The last set of keys for the main warehouse had been returned by Unit 2 nearly an hour ago. The keys on their hooks were motionless. I glanced at the control room door. It was closed, secured. No draft. The HVAC system was running, but its output was steady, not enough to cause such a precise sound. I logged it as unconfirmed ambient noise, a minor error on my part, a product of late shift fatigue and a subconscious desire to avoid logging something truly inexplicable. I convinced myself it was residual vibration from the radio speaker, or maybe the building settling. It was easy to dismiss. About 20 minutes later, Unit 1 radioed in from the south yard, requesting a forklift for a pallet adjustment. I acknowledged the request, and again, as the radio's carrier tone bled out, the same soft chime sounded from the key rack. This time, I was watching it. The set of keys for the maintenance garage hanging on hook number 7, visibly swayed, producing the sound. It wasn't a violent swing, just a gentle, almost imperceptible movement, enough for the metal to kiss the adjacent keys. Still no one near. Still no draft. The control room door remained shut. This was a violation of procedure. Keys did not move on their own. I stood, walked over to the rack, and examined the maintenance garage keys. They were still. I reached out, touched them. The metal was cold. I tried to replicate the chime, gently nudging them. They swung, of course, and made a sound, but it wasn't the same. The previous chime had a specific resonance, a purity of tone. And crucially, it had a half-beat delay after the radio's carrier tone dropped. Always that delay. I checked the security camera feed for the control room. The camera was mounted high in a corner, providing a wide-angle view. Reviewing the footage for the last half hour, I saw myself at the desk, saw Unit 2 return the warehouse keys earlier, but at the times of the chimes, the area around the key rack was empty. The keys simply moved. The camera's frame rate wasn't high enough to capture the initial precise movement, but it confirmed the lack of any physical interaction. My mind went back to a summer evening when I was a kid, sitting on the porch swing, listening to the gentle clinking of my grandmother's wind chimes in a soft breeze. The sound was peaceful, predictable. This was anything but. I decided to run a systems check. I called Unit 1 on the radio. Unit 1, this is Control. Can you confirm your location and activity? Control, Unit 1. Still at South Yard, waiting on the forklift. What's up? Negative, Unit 1. Just a comms check. Carry on. I didn't want to sound like I was hearing things. I wanted to observe. As Unit 1's transmission ended, the carrier tone faded, and precisely half a beat later, the chime rang out again. This time, it was the keys for the main office, hook number 3. They swayed, just enough to produce that signature sound. My gaze darted to the yard radio. Its green TX light was off, but the static had a peculiar, almost internal hum. A carrier bleed tone, a low-level signal that sometimes persisted even when no one was actively transmitting. A ghost in the machine. And the chime matched its frequency, its subtle drone. This was more than ambient noise. This was a pattern. The chime was directly linked to the radio's activity, specifically its carrier bleed, and always with that unsettling half-beat delay. It was as if the keys were reacting to an echo or a delayed pulse. I logged the incidents, meticulously noting times, which key sets chimed, and the radio interaction. I even tried to power down the yard radio, a non-standard procedure. I pulled the main power plug. For a full minute, the control room was quieter. Then the server rack hummed. The distant lines droned, and the air conditioner cycled on. No radio, no carrier bleed, no chime. I plugged the radio back in. The familiar static returned. I waited. Nothing. Then Unit 3 called in again. A quick check-in from the east perimeter. Control, Unit 3. East gate secure, all clear. Roger that, Unit 3, I responded. The carrier tone dropped. And then, the chime. Louder this time, or perhaps I was just more attuned to it. It came from the entire rack. A cascade of small metallic rings hitting each other. A soft cacophony that lasted for 3 full seconds. The entire rack was vibrating. The keys dancing on their hooks, even though the air was still, and no door had moved. I immediately called my supervisor. The protocol for unexplained auditory phenomena coupled with physical movement of secured assets was to report it up the chain. When the supervisor answered, his voice thick with sleep, I explained the situation, trying to keep my tone factual, devoid of panic. "Keys chiming on their own?" he grunted. "Are you sure you're not just tired, lead? Maybe the radio's got a short causing interference. Or a draft." "I've checked for drafts, supervisor, and the camera feed shows no one near the rack. It's tied to the radio's carrier tone with a half-beat delay. And it's getting stronger." He sighed. "Look, log it as a possible electrical fault with the radio. I'll get maintenance to check it in the morning. Don't go chasing ghosts. Just keep the logs updated." He dismissed it. The protocol, designed for clear and present threats, seemed to have no category for something so subtle, so impossible. I felt a chill, not from the room's temperature, but from the realization that the system had no answer for this. I sat back at the desk, the radio static a constant presence. The key rack was still now. I knew what I had heard, what I had seen. The carrier bleed tone from the radio continued its faint hum. I watched the keys, waiting. The silence was heavier than before, pregnant with expectation. I knew it would happen again, and I had no idea what it meant, or what would happen if the chime finally came without the radio's trigger. I've been a yard foreman for a little over 15 years now, overseeing operations at a major distribution hub in the Central Valley. My days are usually a predictable rhythm of inventory checks, equipment dispatch, and security rounds. We handle millions of dollars in goods daily, so security isn't just a formality. It's the backbone of the entire operation. Every piece of equipment, every gate, every secured storage unit relies on a robust system of padlocks and accountability. Our padlock management system is simple, effective, and has been in place for decades. A heavy oak lockboard hangs in the main office, fitted with numbered hooks. Each hook corresponds to a specific padlock, engraved with its matching number. When a crew needs to secure a gate or a trailer, they sign out the corresponding lock from a hardbound ledger on the log bench. The entry includes the lock number, the time and date of checkout, the destination, and the signature of the person taking it. When they return the lock, they sign it back in, noting the return time. It's a physical check and a paper trail, designed to be foolproof. A lock is either on the board, actively signed out and in use, or returned and logged. There's no third option. This system is what I rely on, what keeps the yard secure and my job manageable. This particular morning started like any other, a low fog clinging to the asphalt, dampening the usual rumble of early morning deliveries. I was making my first round, coffee still warm in my thermos, checking the lockboard against the overnight log. Most hooks were filled, a few empty for locks still in use. My eyes scanned the ledger, confirming entries. Everything matched until I reached lock number 17. The ledger showed it had been checked out yesterday afternoon by the night supervisor to secure the east hasp on the old storage unit, then returned at precisely 05:45 this morning. The supervisor's familiar looping signature was clear. My gaze flicked to the lockboard. Hook number 17 was empty. That was odd. If it was returned, it should be hanging there. My first thought was a simple oversight, Maybe the supervisor forgot to hang it up and just left it on the log bench. I walked over, scanning the bench, then the floor. Nothing. I checked the log again, running my finger across the entry. Returned, 0545. No ambiguity. A small prickle of unease started. The east hasp. That's where lock number 17 always went. I decided to make a quick trip out to the east side of the yard, past the stacks of empty pallets and the dormant forklifts, just to be sure. The air was still and cold, carrying the faint metallic scent of damp rust from the old containers. The east storage unit, a corrugated metal structure we used for long-term overflow, loomed in the mist. I approached the main access door, my boots crunching on the gravel. And there it was. Lock number 17, a heavy brass padlock, secured through the hasp, holding the door firmly shut. My breath caught. It was physically impossible. The log clearly stated it was returned. The night supervisor had logged it in. Yet, here it was, in place. I reached out, my fingers brushing the cold metal. It was undeniably lock number 17. I pulled on it, just to confirm it was locked. It was. This wasn't a lock left open, or a mistake on the board. This was a direct contradiction to the ledger, to the very foundation of our security protocol. My initial thought, that I must have misread the timestamp on the log, evaporated. The time was clear. The entry was clear. The lock was clear. I pulled out my radio. "Night supervisor, you there?" "Go for night supervisor," came the crackle. "About lock number 17. You logged it in this morning. 0545, correct?" A beat of silence. "That's right, Foreman. Secured the east hasp, then put it back on the board." "You're sure you put it back on the board?" I asked, trying to keep my voice even. "Why?" "It's still on the east hasp," I said, the words feeling heavy. Another, longer silence. "That's impossible, Foreman. I personally locked it and returned it." The protocol had failed. Not just a human error, but a complete breakdown between physical reality and recorded fact. I needed to get that lock off the hasp. I walked back to the office, retrieved the master key for our padlocks, and returned to the east storage unit. The fog had begun to lift, revealing the pale morning sun. As I approached the hasp again, my eyes caught something else. Something subtle but distinct. The hasp itself, a flat metal plate, was coated in a fine, uniform layer of dust. But, directly beneath the shackle of lock number 17, where the body of the lock rested against the metal, there was a neat, clean oval traced in the dust. It wasn't just where the lock sat. It was as if something had pressed against the dusty surface and then turned, leaving a distinct, smooth, almost polished impression. It looked like the outline a wrist might make if it had been pressed down and rotated slightly. I stared at it, a chill running through me despite the warming air. A wrist? Why would a wrist be there? And if the supervisor had returned the lock, how could this trace exist? If they had removed the lock, handled it, then returned it to the board, this impression would have been disturbed, wiped away. This trace suggested something had been there, applied pressure, and then simply left, without removing the lock. I took out my phone and photographed the lock in place, then zoomed in on the dust trace. I took several angles. The oval was perfectly clear, an unsettling negative space in the grime. Then, with a slow, deliberate movement, I inserted the master key into lock number 17. The tumblers clicked, a sharp, metallic sound in the quiet yard. I pulled the shackle open, removed the lock from the hasp, and let it hang from my fingers for a moment, heavy and cold. The dust trace on the hasp was even more pronounced now. A silent, impossible signature. Back at the log bench, I laid the lock down next to the open ledger. The photos were on my phone screen. I tried to reconstruct the events. The supervisor's account was unwavering. Locked, returned, logged. My own observation was equally undeniable. Lock in place. Dust trace undisturbed. I thought about the time my son had tried to convince me he'd finished his homework, only for me to find it untouched on his desk an hour later. That was a simple lie. This felt different, more fundamental. I called the supervisor again, describing the dust trace. There was a long pause. A trace? Like a handprint? No, I clarified. More like a smooth, oval impression. As if something pressed and rotated. I don't know what to tell you, Foreman, they said. Their voice now edged with genuine confusion. I just know I locked it and put it back. I spent the next hour poring over the log, comparing the supervisor's handwriting, the timestamps, everything. It was all perfectly consistent. The lock itself offered no clues. Just a standard, well-worn brass padlock. The only anomaly was the impossible contradiction between its recorded status and its physical location, compounded by that bizarre dust trace. The fluorescent lights above the log bench hummed, a low, constant vibration that seemed to emphasize the unreality of the situation. I filed an incident report, detailing the discrepancy, attaching the photographs. It felt absurd to write it, as there was no actual incident of theft or damage, just a paradox. We implemented a new, stricter double-check system for lock returns, requiring a second supervisor to visually confirm the lock on the board. It felt like a Band-Aid on a phantom wound. Lock number 17 was eventually put back into circulation, but every time I see it now, hanging on its hook, or in someone's hand, I remember that neat oval in the dust, the system I relied on. The concrete reality of our operations had shown a crack. And I still don't know what or who left that trace, or how a padlock could be simultaneously returned and still secured on a hasp.